Alright, in the last video we spent a lot of time, and I do admit it was a little bit boring just talking about the volume shader, but if you did find it as an interesting video, awesome. Okay, in this video we're going to move a little bit quicker here, and we're going to explore method number 2 of applying these volume shaders to our particle clouds. It doesn't take very long to apply these volume shaders to our particle clouds using method number 2. I'm going to show you why that is. Select the point cloud. We'll come over here and switch from simulate mode. We'll switch to model mode, and the shortcut on the keyboard is 1 to do that. And we'll go to material over here, and then you'll notice in this new material menu in exercise 7 we have ice particle volume. Go ahead and click on that. Okay, close the PPG that opened up, and now with the point cloud selected, hit 7 to open up the render tree. Wow, wasn't that amazing? By selecting the ice particle volume shader in the material menu over here, what XSI did was it automatically created the shader network we need to go ahead and get these particles to render out correctly as a volume. And if we create a render region, you'll notice that that in fact is the case. Okay, so what in the world happened here? Well, essentially what these nodes down here are, the particle renderer and the particle shaper, they're compounds. In exercise 7, compounds are basically these one node containers which contain several nodes, a whole network of nodes inside of them. If you want to know more about what I'm talking about, simply hover over the particle renderer compound, for example. You notice there's this little E icon over here. It's a gray circle with the letter E. If we click on that, the render tree changes, and we can now look inside of that compound. As you can see, we have a network here of a few nodes, and then we have all these lines and things that are going over here to the left. And we're not really going to talk about these compounds and things like that in this particular video, so we're just going to move on here. But let's go ahead and close that by hitting this little X button up here on the top left. And you just got a sneak peek inside of this particle renderer compound. The particle shaper is also a compound. One quick way to identify compounds in a render tree, if you look at the actual node, if it has this border around it, see how it has this extra border around it? Almost like there's this object behind it. That means it's a compound. And also when you hover over it, you'll see this little E icon pop up. All compounds have this little E icon, so you can click on them and have a look inside of them and dig in here and see what you can find and edit. So we can see we have quite a large network of nodes inside of this particle shaper compound. Let's click on the little X up here in the upper left to get out of the compound. Okay, so essentially by clicking that one option in the material menu up here in the model, material ice particle volume, exercise 7 went ahead and created all the connections we need to make this volume effect work. So this works a lot faster than method number 1 that we saw in a previous video. So you might want to use this method if you're beginning, or if you simply just want to go through this very quickly, just use this method number 2. If we open up the particle renderer compound, we get some options here. Okay, we don't get as many options as we did in the previous method when we were using the long and more advanced way. That's because this compound only exposes a few key parameters. In this case, it exposes the density parameters, a few density parameters, a particle, a simple particle parameter, some volume colors that we can use to adjust the ambience of the particle effect. In this case, I'll knock it all the way down to 0. We also have some diffuse illumination parameters that we can control here. And then we have some volume rendering parameters to control the quality and the speed. For example, for marching, we can control the detail from low, default, and high settings. We'll set it to low for the moment. And you should recognize that setting from one of the previous videos when we looked at the particle volume shader parameters, and we were looking at the different settings. Down here we have the cell tables parameters, so we can set the interpolation for the cells to linear, cubic, or as you remember, full light trace, which takes longer to render but looks nicer. And of course the cell size, again, the smaller the cell size, the longer to render but the higher quality. Large cell sizes equals faster renders but lower quality. And then we have our memory limit here to protect us from fatal crashes and things like that in XSI. And then we have the fast preview for region button here, which allows us to go ahead and create these render regions with very fast render. Okay, edit some of that stuff out of the video. There was a bird in the background, a bird in the background. Shit, it's still there. I think the bird stopped. Don't know, he might come back, who knows. So, let's start again. Okay, start again in 3, 2, 1. So we have here our interpolation type that we can choose like before. Okay, there were nice little orange Orioles, but seem to be gone now. So let's go ahead and pick up where we left off here in 3, 2, 1. Down here under the shadow table parameter set, we have the different interpolation methods that we can use. For example, linear, cubic, and of course the full light trace, which takes longer to render. We also have our cell size over here. If you remember from the previous video, smaller cell size equals longer render times but higher quality. Larger cell sizes equate to lower quality renders but faster renders. And then of course we have our memory limit, which prevents us from crashing whenever we exceed the limit. So it's a good safety precaution to have. And down here of course we have the shadow table, enable fast preview for region option, which allows us to render this out quickly but at a price of quality. Okay, so let's close that PPG and let's have a look at the particle shaper. In the particle shaper we have very few options. We have a cell shape and a fractal shape. Basically what the particle shaper does, it's a compound and it includes the cell fractal and what it includes is the cell scalar and the fractal scalar nodes that we were working with earlier. And this allows us of course to come in here and change some of these settings around. We also have some ambient occlusion settings here. And then we have some presets, so you can set up some billowing smoke or some fluffy clouds. So let's have a look and see how we can use that. Let's click on fluffy, render that out, and this is what we get. If we select billowing, it'll go ahead and adjust the parameters for us automatically, so we get a different type of particle effect, as you can see in the render region here. Okay, then we have an irregular shape parameter here, which we can adjust and change. If you notice, every time we change the presets, these settings here will actually change accordingly. And you can save your own presets actually as well. If you come over here to this little folder icon, you can set up a preset that you like and then just save it out so you can keep using it over and over again later on. Very useful. Okay, now let's talk about the particle gradient shader to control color. And this is a shader that we didn't talk about in previous videos, so it'll be totally new to you in this video. Let's go ahead and open up the preset manager, and in the particles category we want to go ahead and grab ourselves a particle gradient, which is this one right up here. So let's just drag that right in here, close that, and here we go. Let's open up the particle gradient. This is what we have. We have two tabs, this one very large tab, and then we have this second smaller tab over here, which allows us to set some colors for the particle effect, because as you notice when we were rendering out, the particles are now coming out yellow. They're basically inheriting the color from the particles in the ice tree. If I go ahead and hit Alt and 9 to open up the ice tree, and I go ahead and open up this node up here, the emit from surface node, you notice that the color is set to yellow. But we may not want to have yellow as the color. So let's adjust the color using the particle gradient. This is what we'll do. We'll take the particle gradient here and we'll drag it and connect it to the particle renderer compound over here. Now we have a few different places where we can connect it to. Usually where you want to connect it to is under the per cloud or gradient section here. You want to connect it to the global/gradient color. Okay, by doing that, let's go ahead and render this out and you'll see what we have. Now the particles are no longer being rendered out with the color from the ice tree. They're being rendered out with the color coming from the render tree from this particle gradient node, as you can see. And all these different colors are appearing here because of course the gradient has these different colors. Okay, so we can choose a few presets down here. We can choose this fire preset, we can choose this white and black, we can also choose this black and white. And of course, we can also make our own gradients. I'll go with black and white because it looks pretty good. Okay, so this is our black and white preset here. Okay, here's the way it works. Down here, the color that's being taken into account is this color here on the far left of the gradient. The color on the far right of the gradient is the color that's appearing up here toward the top. Okay, so that's very important to remember. If we switch over here to the gradient position tab, we have all these different parameters down here. We have up to 6 inputs that we can work with here. Most of them are turned off except for these first two. Let's work with the first two inputs up here. The first input is the per cloud density, and the second input is the per particle age percentage. Right now the default setting is set up like this. The gradient starts at position 0. The gradient ends at position 1. So what does that mean? Well, it's pretty simple. If we go over to the RGBA gradient tab over here, I'll show you what that means. Basically, the gradient starts at 0 is telling the material here, the shader, that the first position is over here on the 0 because the far left is position 0, and we can see that down here under this POS, which stands for position. It's position 0. If we click and select the white color swatch over here, you'll see that's position 1. If we left click on the gradient over here somewhere in the middle, doesn't really matter where, you notice the position updates there interactively whenever we move this color swatch around. So as we move this over here to the left, it's at position 0.37. We can also put this at position 0.5, which would be halfway through, or 50% of the way there. And you'll notice that now position 0.5, or 50%, is right smack in the middle of our gradient. So basically the way this works is pretty simple. Gradient starts tells the per particle age percentage when the gradient starts. So we can actually change that. We can tell it to start the gradient at position 0.5. And now the gradient's going to start at that gray color, which we had set up over here. So let's change it from a gray color to something else. Let's change it to maybe a green. And this is just starting to slow down because I've got this render region over here open. So let me go ahead and switch that to, say, green, maybe a bright green, a brighter green. Okay, and that green is set up at position 0.5. So let's bring out a render region again, and now we can see, in fact, there's our 0.5 green color right there coming out in our particles. And ooh, that looks actually pretty interesting. That's a really interesting particle effect there. These volume shaders are so much fun to use, and you can do so many cool things with them. It's insane. And then the gradient ends at 1. Okay, basically what that's telling XSI is, well, the gradient ends at position 1, which is where this white node is. So we can actually offset this and choose where we want the gradient to start. We can have the gradient start at a position over here at about 0.3, and we can have it end at 0.7 over here somewhere. And we can do whatever we want. So it gives you a lot of options, a lot of flexibility. And down here, the intensity and influence allows you to control how much influence, how much intensity this per particle age percentage input has over the overall particle effect. So if we put the intensity and influence all the way up, you're going to notice that the effect that's being caused by this input here of the per particle age percentage is now taking more control, and its effects are starting to show through a lot more. So I'll put it down to half, 0.5, how it was before. Okay, and up here we have a per cloud density. And again, it has similar parameters here where we can set up the gradient starts at wherever we want, and the gradient ends at wherever we want as well. And we can also change the intensity and the influence. If we take that intensity all the way down to 0, you'll notice that these numbers are grayed out up here. Basically what it does, it turns off the per cloud density input up here, which leaves us, of course, with this effect, which looks like a pretty neat little cloud effect. You can put that in your background scenes and things to make some realistic volumetric clouds, something that was extremely difficult to do in XSI before version 7. Now it's very easy to do. Clicks of a few button clicks, and you're there. Okay, so that's the particle gradient shader. Let's have a look now. Let's cancel out that render region. Let's have a look now at the particle gradient F-curve shader. Let's open up the preset manager. You notice we have a particle gradient F-curve node right here. So let's click and drag that in here into our render tree here. Now let's open it up. And you notice it only has one parameter, and that is this function curve that allows you to go ahead and adjust something. What can we adjust? Well, we can adjust a lot of different things. For example, let's take this particle gradient curve and let's plug it right into the particle renderer compound. And now we can choose which port we want to connect it to. Let's go ahead and let's connect it to, say, the global gradient density. Okay, so we'll connect it straight there. And now let's go ahead and perform a render region here and see what we have. Okay, so this is what we have here. Let me go back to the particle gradient here. And I'll put this intensity influence for the first input here, the per cloud density, and put that back at 0.75 where it was before. All right, I'll close that and let's open up the particle gradient F curve again. Now let's start to adjust some of this stuff around. So let's take this curve up here. We can select these keyframes simply by dragging a selection box around them, and it'll be highlighted in red when we have them selected. Then make sure that you have this tool selected over here, this arrow icon here, and just click and drag wherever you want. We can also click and drag these handles to control the fall off and the curvature of this F curve. And right now what this F curve is controlling is the global density of our particle renderer node down here. As you can see, that's where we connected it to. We can connect it to a lot of different parameters, but this is the one that we connected it to in this instance. And you can see how it's controlling the density of the cloud. The cloud is not so dense at the top anymore. So essentially what's going on here is the cloud has basically no density down here. Immediately, however, its density increases to about a value of 1. Now, you can't really tell what value it has right here, so if you want to be more precise, you can right click on top of the little keyframe right there and go down in the submenu to Key Properties. This opens up a new window where you can set the value exactly to what you want. In this case, the value is set to 1, which is basically 100%. That means that down here at the bottom or the beginning of the particle effect, the density is full, 100%. That's why it doesn't look like it changed much down here, because it's 100% of how it was before. However, right after it reaches that 100%, it starts to drop off and dissipate, so to speak. So that's why the top up here looks like it starts to fall off. The density gets weaker and weaker and weaker until the cloud basically just turns into this soft mist that disappears and dissipates in the air. Okay, so basically what you do is you take these function curve keys and you move them around. By moving them around, say up here like this, what I just did was I continued the global density up here at about a level of 1. It's actually a little bit above that, but that's okay. And it stays at 1, and then it just falls off. So right now it's very dense, very dense, very dense, and then here it starts to fall off and fall off up to here. Of course, that happens right at the end. That's why it's so hard to see here in the render preview. Okay, so if I disconnect this, you notice now that the density is very strong up here on the top, much stronger than before. You can see right there, there it is. It's very dense, very strong up here. So that's what the F curve allows you to do. It allows you to control the density of the cloud. So basically, the cloud or the particles up here can start to fade off once they reach the limit of their lifespan up here, based on however you set up this function curve or this F curve up over here. We can create new keys to this F curve as well, and it's very easy to do. To do that, first of all, let me close this render region because it's really slowing us down. You'll have this key icon up here with a little plus icon. Click on that and then just click anywhere on your curve. So I'll left click right here, and there we go. We now have a new keyframe here. I can drop this keyframe down here, for example. Then I can take this one and move it up here. So now I have this strange curve where it gets really dense, drops off, gets really dense again, and then drops off again. So let's open up a render region here and see what kind of effect that creates. So basically this particle gradient F curve gives you a lot of control. As you can see what we did. It gets very dense, which is down here at the bottom. Then it drops off, which you can see right about here, right after the beginning of the particles. It gets pretty soft right about here, and you can kind of see through it. The density just falls off, and then it gets really dense again, which is up here, and then it drops off again gradually down here, which is up here in the top. So it gets dense, drops, dense, drops. Over here you can see it's dense, drops, dense, and drops up here. So the F curve is very important, and you can use it to control different types of attributes, different types of settings, and you can use it to change the look of your particles. It gives you a lot of control over your particles. Opens up the possibilities by a huge amount. Okay, what I'm going to do is I'm going to disconnect the particle gradient F curve, close out that render region right there. Okay. And let's go ahead and make sure we have the point cloud selected. Hit Alt 9 to open up the ice tree over here. And we're going to go ahead and open up the preset manager, and let's go down to, say, modifiers, and let's grab one of these different color nodes. Say for example the turbulized color by gradient. Yeah, let's go ahead and use that. We'll drop that into the ice tree here. Okay. And I'm going to take the output here, drop it into the emit from surface compound, and I'm going to go ahead and drop into the initial values, color. There we go. Now let's open this up, and this is the color that we get. It starts off red, drops off into white. Perfectly fine for this example. Okay, go back to the first frame and play this. A little bit hard to see because the lights in my scene are so bright, but this in fact is getting some red shading. Okay, so I changed the particles to the red color. However, if I render, you notice I still get that green and grayish cloud that we created earlier in this video. So how can we take the color from the ice tree and apply it in the render tree so that our particles render out like that with mental ray? Well, there's a special shader, special node in exercise 7 that lets us do that. Let's go to the preset manager. We'll go to this new attributes category, which is totally new in exercise 7, and we have these different nodes that we can use. These nodes allow us to pull in different kinds of data from the ice tree and apply them into the render tree. So you can get vector data, transform data, scalar data. I think you get the idea. What we want is color data. So let's click and drag the color node in here into the render tree, and that creates this attribute color node. Let's open it up. In the attributes, we can go into the drop box and grab an attribute, in this case, the color from the ice tree. We'll close that. We'll take this attribute color and we can plug it straight into the particle renderer node over here. So let's go ahead and do that. Let's take the attribute color and let's plug it in. We can replace the current particle gradient, or we can just place it in the particle color. So let's go ahead and place this, say, in the global gradient color, just to replace the particle gradient and have this thing controlling the color. Now let's render again. Okay, just edit that part because it wasn't working, but I got it working now. So start again in 3, 2, 1. So what we'll do is we'll take this attribute color and we'll plug it into the particle renderer. Let's go ahead and do that. Let's drop it in, and let's go ahead and plug it into the particle color up here. All right, and let's perform a render region. And you can see that it's still coming out green. That's because we still have this particle gradient node connected to the particle renderer. So let's disconnect it. So now the particle gradient is no longer in control of the color. And now you'll notice that our cloud turns into this pink color with some shades of red. So it kind of fluctuates from light to dark. And that's happening because the attribute color node is pulling in this color information from the turbulized color by gradient node from the ice tree, and it's applying it to the render tree so that it renders out with mental ray. So it's a pretty awesome way of pulling data like colors from the ice tree and applying it in the render tree to your particle clouds. And the attribute color node allows you to do that. So it gives you a lot of flexibility and opens up a lot of possibilities. So you can set up your colors either in the ice tree, using some of these nodes like turbulized color by gradient or modify color and all that, and then just applying those colors here in the render tree using this attribute color node. So there we go. Now you got started on the, this will get you started on using these new particle shaders in exercise 7, these new volume shaders and some of these extra shaders that help you out, like particle gradients and F-curve shaders and things like that. So that's going to do it for this video. In the next video, we'll continue working with ice and move on to the next topic.